Channel ICSE with Rishi sir. This is your class 10 physics second lecture. The chapter name is force, and in the previous lecture we have discussed about the basics of force and why the force is actually a vector quantity that I can explain. In this video I am going to explain about the types of force. This is very important, and for class 12 you can compare the various types of force. Okay, so before we start the types of force, first of all, again I am going to explain what is force. A force is the physical cause which changes or tends to change either the dimension of the body or the state of the body. That is, the state of the body means the inertia. That is, the body either in rest and or in motion. If a body is in rest, then it can change from its rest state to the motion state, or if a body is in motion, then we can stop that body by applying the opposite force to it. So that is the basic concept of the force. Now there are two types of force. One is the contact force and another is the non-contact force. That is the, I am writing it in the second page, that is the non-contact force. Now what is contact force? What is contact force? That is the force which we exerted by a body with contact. That means the physically we can, the force is physically affected. That is, we can physically we can feel the force. Okay, that is the contact force. So there are so many types of contact force. One is the you can say that frictional force. Second is the normal reaction force. That is, and third one is the tension force. Fourth one is the force exerted by the spring. The spring force, that is very important. That can make a SHM in class 11. You can go through that spring force, and that the force due to the that force the SHM can take place. Okay, and the fifth one is the force exerted by the collision. That is, the in that force the momentum is conserved. That is, the momentum means the P, that is denoted by P, momentum, and momentum is nothing but the mass into velocity, m into v. Okay, and momentum is also a vector quantity. Now, so if we start about the contact force, then frictional force. What is frictional force? You know, it is very important for class 12 physics when two bodies are in contact. So this is the surface and a body is kept over here. The surface of the body is unduled, or if a surface is not unduled, that is, if the body is the regular surface and you keep one mass over here, the m mass over here, this is also mass m over here, then, and if you apply some force on it, then the body, the mass can be moved or tends to be moved. Okay, so the force between this surface of the body and this surface of the this surface where the body is, the mass is situated, and this surface of the this surface and the mass, the surface of the mass which are in contact, they have a relative motion. Why they have relative motion? That means if you apply a force, then the mass is moving in this direction, that is accelerating in this direction, and for that it is not easier to move the body, because another force which is acted on the body, that is called the frictional force, and the frictional force is opposite to the applied force. It means that is the, it can change the force can change the inertia, and inertia is nothing but the mass of the body, and if mass is more, then the friction is more. But friction is the limiting force, because and the friction is a self-adjusting force. That means friction, if there is a heavy mass m, and if you want to apply some force over here F, then it cannot move. You are unable to move. Then you again with your friend, he also apply some force, and then this mass tends to move. That means why this mass you cannot move, because due to the frictional force. That means you want to move the body in this direction, but the force of friction is applied on the surface of the this mass and the surface, and it is in the opposite direction. And if force is more, then frictional force is more. When this force is more than this frictional force, then only you can move the mass, otherwise you cannot move the mass. That means if we apply 5 Newton force, then this frictional force also apply 5 Newton force. If you apply 6 Newton force, then friction is also apply 6 Newton force apply against you. Like that, if 10 Newton force is needed to move this mass, then up to 10 Newton the frictional force can adjust him, because you apply 5 Newton, frictional force apply 5 Newton, you apply 6 Newton, frictional force apply 6 Newton, and both are opposite obviously. Up to 10 Newton, when you apply 10 Newton, then the body tends to move. When you apply greater than 10 Newton force, then the body is moving with some velocity. Okay, so this is the frictional force. That means the force, the force which is when a body is slided over a surface, means one surface, and the some mass is kept over there. So, and if the mass is slided over the surface, the force acts on the body in the direction opposite to the motion of the body. That is the frictional force. Okay. Now, next force is nothing but the you can say that the normal reaction force. This is very simple concept. This is also comes with inertia. That means if you keep one mass over here, then the mass is static. Why the mass is static? Because the net force F net is equal to 0. That means the static equilibrium. If the mass is static or static equilibrium, it means that the force which is acted over a mass is a 0, net force. So what are the forces acted over here? The force which acted over here is nothing but, first, that is the weight W is equal to that m into g, that is the g is the acceleration due to gravity. And why this is static? If this is, as it is static, that it means that there should be some another force which is acted opposite to the mg, and as that opposite acted force and the mg both are equal but opposite in direction, that's why they can cancel out each other, and then and in that case only the net force acted on the body is 0. That means here some other force is acted on the body, that is called the N, denoted by N. N is nothing but the normal reaction force, which is equal to the mg. That's it, the N equals to mg. That's why the body is static. If N is more than mg, then the body starts accelerate upward. It means that if you apply some force in this direction, then you can lift the mass. So that means then in that case the upward force is N plus your applied force F, which is greater than equal to mg, then only the mass can be lifted upward. This is the normal reaction force. Third one is the tension force. This is another simple concept. So if this is a rigid surface and if hang some mass over here, okay, so let's write down tension force. This is the mass M. This is the mass M. Now, what are the force acted on over here? The force acted over here is, this is the M into G. And as it is hang and it is in static equilibrium, it means that it has also another force which is acted over there. The force which is acted opposite to the mg, that can make this mass in the equilibrium position. That means there is some another force which is called the tension force, which acted through the string or or this rope. And the tension force, you keep one thing on your mind, that the tension force is always away from the mass. The point here, it is the point of the force. In that point all the forces are acted. So tension force is always acted away from the point of the force. Okay, so this is the point of the force. So mg, and as T is equal to mg, if that's why this body is in the static equilibrium. Is mg is greater than T, then the thread can cut out and the mass is fall down from here to here. So this is the tension force, a simple concept. Now fourth one is the spring force, very important concept, spring force. So spring force is F, if the spring force is denoted by F, is equal to minus of K into X. This is the formula for the spring force. Why this is the F is equal to minus Kx, where X is nothing but the displacement. That means the how much you can displace the spring, that means how much you can stretch or you can uh, squeeze the spring, and K is the spring constant. K is called the spring constant, which is dependent upon the material of the spring and the shape and size of the spring. That means why it is minus, let's show you one thing. So if this is your spring and one mass is connected over here, this is the M mass connected over here. Now you stretch the spring, what happened? The diagram should be like this. Diagram like this is the diagram after stretching. That means initial position is this and the final position is this. That means this is the displacement of the spring. Now you apply some external force, and F external, external, external force is applied over the mass M, and due to that the spring is stretched, and the spring is stretched at a distance of x. Now what is the tendency of the spring? The tendency of the spring is to go back its original position, or it can regain its original position, and for that the spring applies some force. That means if the displacement is in this direction, then the force by the spring that is the force applied by the spring is the opposite to it. That's why F is equal to minus K into X. Okay, so now K is what? K is a spring constant. It means that you see the spring on your pen, TikTok pen, so you can easily stretch or you can easily compress the spring. Now if you have seen the shocker of your bike or your scooter, so that is much more thicker than the spring of the pen. So if I say you that can you stretch or can you compress the spring by your hand, it is impossible, because the spring of the bike or the scooter is much more thicker and the material is obviously not the same like the pen. That means that if K is more, then the force is the more. That means if the spring is much more tight and spring is much more thicker, then the force, which is if you stretch the spring, then it will apply the more force to regain its original position. So this one is the fifth type. Fourth type. Fifth type is the force exerted by the collision. That is a simple concept, but it is obviously one thing you have to keep in your mind, that in that case the conservation of momentum, this concept, that is the force exerted by during collision, this concept will help you to know how the conservation of momentum can be. That is the conservation of momentum theorem can be proved by this force exerted during the collision. So if there is a mass A, body A, and there is a body B, and after the collision, when collision takes place, so both are coming in this direction, that is the both are coming towards each other, that is the head-on collision is there, and after colliding, the body A move in this direction and the body B move in this direction. Okay, now if it has a velocity of u1 and your velocity of u2, and after collision the velocity become v1 and v2, then if it has a mass m1, it has a mass m2, and it obviously mass cannot change m1 and m2, then we can say the momentum before collision is equal to the momentum after collision. What is momentum? Momentum is a vector quantity, is p is equal to m into v. So m1 u1, you can write m1 u1 plus m2 u2, that is the momentum before collision, is equal to m1 v1 plus m2 v2. This is the conservation of momentum. Okay, these are the contact force which we can we have in our syllabus. Now, the non-contact force. The non-contact force is nothing but there are few types of non-contact force. One of them is the gravitational force, and another is the electrostatic force. First one is the gravitational force. That is we cannot see the force, but there is we see the effect of the force. That means that the force due to pull of gravity or the earth attraction is called the gravitational force. Okay, it causes the motion of the body downward. That means due to that the acceleration takes place. So this is your earth. So if you can say that center of earth is this, and the total mass is concentrated on the center of the mass. If you throw something from upward, then it goes to the downward direction, and it is directed to the center of the earth. So this is the gravitational pull. Okay, this is the gravitational pull, and due to that acceleration which takes place, that is the g. G is the acceleration of the gravity, acceleration due to the gravity. Okay, so that means that a ball placed on a table starts rolling down when a table is tilted. That means that when this is your surface, a ball is kept over here. Now this is tilted, the ball is rolling down. Apple is falling from the tree. That is the myth of the Newton's laws of motion. All these things are due to the gravitational force. Very simple thing. Another is another thing we can say that the gravitational force, that is G, is nothing but the acceleration due to gravity. Another thing is that this is one mass m1, another mass m2, which is kept a distance r apart. This is m2, which are kept at a distance r apart. Then they have the force of attraction with each other. The force is called the gravitational force. F is equal to m1 m2 by F proportional to m1 m2 by r square. You can individually F proportional to m1 m2 and F proportional to 1 by r square. That means that it follows the inverse square law. So F is equal to G m1 m2 by r square. G is called the universal gravitational constant. This is also a constant we have in our syllabus for class 11 and 12. Okay, so this is one criteria we can by which we can determine the gravitational force. Then the electrostatic force. If we consider the electrostatic force, then we can keep two charge q1 and q2 by some distance r. They have a force of attraction. If they are in the same type, that is both are the positive charge, then they have the force of repulsion. If q1 is the positive and q2 is negative, then they have the force of attraction between them. And if they are denoted by F, that means the F, and that is the F. So that F is proportional to q1 into q2 and F proportional to 1 by r square. Then we can say that F proportional to q1 q2 by r square, or if we eliminate the proportionality, the proportional sign, then we have to apply some proportionality constant. F is equal to k q1 q2 by r square. K is equal to 1 for air or vacuum. Basically K air is equal to 1.00054 and K vacuum is equal to exactly 1, and K water is equal to 80. That means the electrostatic force between the two charges separated from distance r is 80 times greater than the same charge if kept under the water at the same distance. Then the force between them is decreases by 80 times. But it is one important thing is that if you compare the gravitational force and the electrostatic force, it is important that gravitational force does not depend upon medium. That means that G is always constant for for any kind of medium, so that means that if two masses are kept in air, in vacuum, under the water, whatever it is, they are kept, the universal gravitational constant G is always constant. But depending upon the medium, if we change the medium, and then the electrostatic force is decreases. The maximum electrostatic force that can be repelled or attracted by the two charges separated from distance r is maximum for vacuum, and next for air we can consider kar as 1.00054 or approximately equal to 1. So these are all about the contact force and the non-contact force, and in the next class we can we can go through an extra topic, that is the we can compare the gravitational force and electrostatic force. And you comment me one thing, that which force, what do you think, which force is greater, gravitational force or electrostatic force? Please give me a comment. Thank you for this video. We will see in the next video with the comparison between the gravitational force and the electrostatic force.